Hello, this is Dr. McKenzie again, and here is yet another video on multiple attribute decision making. As you see, I have a table here of football players. I will zoom in so you can see them. These are quarterbacks. As you can see in column A, their name. You may recognize some of them. In column B, you can see that they are quarterbacks, their team name, whether or not they had byes, some other information on notes and ranking. You can see in columns G and I 2 scores indicating how they were ranked previously, and in H the difference between the old and the new ranking. You see something similar in a standardized scoring in J, K, and L. And then you have some more performance rating in M, N, and O. Additional information, column P. Q is games played. R, games started. Completing, this is passing yards. INC stands for incomplete. So there we have the total yards for their passing completions. Of course, there would be no yards if they were incompletes. So those yards are totally attributed to column S. Whether or not they got a touchdown, column W an interception, or were they sacked in column X? And did they get a first down, and how many yards they got if they did get a first down on that passing play. Column Z, AA, AB, and AC are all about rushing. Did they attempt a rush? And how many yards did they get in AA? Did they make a touchdown? Did they make a first down? Then there's more information about receiving and returns, some miscellaneous information, total fumbles, did they lose possession, the total points given by fans in fantasy football, and points per game points. Okay, so this all information comes from a fantasy football league. The first thing that we do in the multiple attribute decision process is eliminate any redundancy. As you can see below, I have eliminated redundancy based on things like column C, the team name. Okay, I left that. But column B, they're all quarterbacks, so I don't need that. Didn't need column F because there's no information there. Or column E, that's just some notes. Scrolling over column R, they were all zeros, didn't need that. Keep going, column AD, AE, AF, AG, AH, AI, AJ, all of those had zeros, so I eliminated those. Okay, I'm going to scroll down. Redundancy, it added no additional information because it was all the same data, so I got rid of it. And here's my new table. So in this information, I am now going to look and see if any information can be useful. Let's see. Satisficing. That's what I'm going to look at now. I am going to satisfice based on, are there at least 3,000 passing yards and at least 100 rushing yards? I don't want a quarterback if they can't get me any yardage. So as you can see in red in column Q, I identified all the data where I had a quarterback that didn't make at least 3,000 rushing yards, as well as a quarterback who didn't have at least 100 rushing, so passing yards and rushing yards. I didn't want a quarterback whose total game was rushing or total game was passing. In other words, they had to have a good mix of both throwing the ball and handing it off. So I eliminated those quarterbacks. Now, this is the table I am using to do my analysis. Alright, now I'm going to look at redundancy and see if I could eliminate any rows that are redundant. Can you find any redundancy? Pause for a little bit and look. Any quarterback you can eliminate? Alright, let's keep going. As you can see, I have eliminated Roethlisberger. Can you tell me why? Okay, great. Let's keep going. Now, I have a scaling problem. In the table above, let's just take D, E, and F. Can you see the difference in E is indicated by F and D? There's no difference for Kaepernick, so Kaepernick got a 0. But Wilson went down from the old column of 32 to the new column of 33, so Wilson got a -1. The problem here is we would like them to go up. Therefore, getting a -1 indicates that this triangle column is a cost column. Because the fact that Wilson went from 32 to 33 is good, but column E is a negative number. We know this is a cost column. Pause for a minute. Do the same with columns G, H, and I, and J, K, and L. You can see anywhere there's a triangle, these are cost columns. I've also indicated the cost column because incomplete passes, that's not a good thing. Interceptions, that's not a good thing. Getting sacked, that's not a good thing. And having lost possession, that's not a good thing. So all those are costs. In reviewing the cost equation, I'm looking at the lower left, this is minimum cost divided by cost. That's not a problem at all for incompletes and those other variables to the right, but we have a problem with this in the triangle columns because we might have to divide by 0, the actual cost value. So I'm going to use a slightly different scaling technique. Basically, I'm adding a number to all of these numbers to make sure that the lowest value is 1. So I take the minimum value, that's a -6. If I add 7 to everything, all numbers will be positive. And I won't have a divide by 0 error. Similar to column H and to column K. So although we can scale for categorical variables, we can also scale to prevent the divide by 0 error, and that's what I did here. Alright, now that we've scaled, we have to normalize everything using the benefit function or the cost function. And now everything is on a scale between 0 and 1, and everything is now a benefit. So if I look in my triangle column, 1, Jay Cutler is the best quarterback for this change. He had the best change. Okay, so 1 is great. What I did here is try to identify where it is that I might be able to find dominance again. Well, in Cutler's situation, he had a 1, or the best value, in column E. There's no way Cutler can be dominated because he was the best in this category. No one else can be better. So anytime a quarterback has a 1 in a category and nobody else does, for instance, column D, foils, can't be dominated. Cutler can't be dominated because of column E. Column F again, foils can't be dominated. Column H, again, foils is the best. Column I, Bortles is the best, and you can continue looking at that. So you're going to ask me, why do I have some red rows? Well, those are the quarterbacks who didn't have a 1 all by themselves. It is potential that they could be dominated. Well, I checked every single one, and why don't you check? Did I get this wrong? Can somebody be dominating over one of these quarterbacks? Let's look at Carr, the very last one. 0.5 in the first category. Yeah, he could definitely be dominated there. 0.82 in the next category. There's only a couple of quarterbacks who could be better. We have Bortles, Smith, and Foils. If we look over here, Bortles is not better in category E. In category E, Smith is, so Smith can still dominate. And we keep going into category F. Yep, Smith can still dominate. Whoops, not in category G. Scrolling on down. Oops, and Luck can't dominate. All right, looking here. That the only potential, no. I continue to check. Carr can't be dominated either. All right, check for dominance on all the other ones. Scrolling down, I applied weights. And if you're having problems with any of this, go to the smaller file I made on cars. This is a larger file with more data just to show you a real-world example. Here I added the weights. And in doing this, you can see that the winner was Wilson. Wilson is my best quarterback. In using the solver technique that we discussed, what if I wanted to make Carr the best? Right now, Carr's the worst, right? Well, to make Carr the best, I used this formula down here in the bottom where I calculated the difference between Carr and everybody else. And you can see my formula here. I said, okay, let's take Carr's weight minus the maximum of anyone else. If that could be positive, then solver would show me that that is the best result. Let's look at solver. I'm going to reload solver for everybody just so that you know how to load solver. Of course, my computer won't let me load solver here. Alright, and showing you how to load solver, click on File and Options, Add-ins, Excel Add-ins. Click on Solver, say OK, and you now should have Solver in an analysis toolpack. Here's Solver. Here's my objective function. That's that taking the maximum, right? And what am I going to do? Just like we did Solver before, I'm going to allow my weights to change, keeping the weights between 0 and 10, and let it solve. And when it does, I get the result as we see in this lower right hand corner. Let me run it again. I'm going to start with the original weights. Alright, got to do that copy function. Copy it and paste it. Okay, there's my original weights, and you can see that old Mr. Carr is the worst one out there. I go to Data and Solver. Oops. Data. There we go, my solver. And I can see my objective here. And by changing my weights, and I tell it to solve. And there we go. Keep the solver solution because sure enough, it made car the best one. Alright, so that's a review of weighting using a second, much larger example file. I am going to use this example file for part 2 of the course as well. I hope this helped, and good luck.